Hey guys, in this video we're going to talk all about searching data, what it is, what search algorithms are, and why we need to consider them. So to start off, let's think about an analogy we use quite a lot when we talk about searching for things. I am of course talking about this idea of having a needle and a haystack and finding that needle within the haystack. So here we have a haystack, which is essentially just a bunch of unordered things, and we're tasked with finding this needle inside of it. There's so many things inside the haystack that finding the needle is actually quite a hard problem, and this is why finding a needle in a haystack is so hard, because there's so many things in the haystack and we're trying to find such a small thing in the haystack. Now you can think of this as similar to a real life setting. So maybe you lose your car keys, but the reason it's quite hard to find your car keys is because there's so many possible places it could be in. Finding them therefore is quite hard. So in this analogy you can think of the haystack as a data structure. When we're talking about searching data, this is what we mean. The haystack is the data structure and the needle is the item you're looking for in that haystack. So searching for data is the same problem. We have a collection of things, in this case, a data structure, and we're tasked with finding a particular thing within that data structure. Whether that data structure is an array, a linked list, dictionary, or whatever else. So you can think of searching data as the process of finding something within a data structure. And there are many examples of this, which we'll talk about later on. But essentially, searching data is the process of finding if something exists within a particular type of data structure. It's the act of searching a data structure for a particular value. The process might be different depending on the data structure, but generally it's the same process. We're trying to find something in a bunch of data. So as humans, we have this kind of intuitive sense of how to search for things. Think about it. When was the last time you considered the exact algorithmic steps you take when, searching for your keys? My guess is you probably don't think about it too much. We don't really think about how we search for things. We just do it. We have this instinct of how we do it. And depending on the scenario, we do search for different things in different ways. But computers, like in any task we give them, need very specific details on how to search for things. They need algorithms to tell them how to search for things in data structures. And we call these algorithms search algorithms. Now, search algorithms are a very fundamental part of computer science. It's one of the tasks we use most often when we program. We even use these things without even noticing them sometimes. And there's so many ways to search for different values, which mostly depend on the type of data that we're going to search. And we'll talk more about that in later videos. So as a more specific example of a search algorithm, consider this data structure. It's a simple array with 5 numbers in it, which are not sorted in any particular way. So with a search algorithm, we could ask this question. We could ask, does the array contain the value 12? The search algorithm would go off and somehow search this array and then come back with a yes or no answer, or potentially also where the number 12 was located in the array. So it searches the array for that particular value. So we have a good idea of what a search algorithm is, but the question that might be on your mind now is, that's great and all, but why? Why do we need to consider these? Well, there's many reasons, but the main one is that search algorithms come up all the time in computer science. And one of the things we rely on as programmers is data structures in our code. Having the ability to search those structures for particular values is a very important aspect of programming. So here's some more realistic examples. Say you have some kind of search function in your software, like this on the left. Here we're searching for the word lasagna, and it's returned some results for us. In this case, vegetable lasagna, beef lasagna, and chicken lasagna. Now, whenever you see this, there's some kind of database or some kind of data structure that the data is being retrieved from. The process of searching a database for items that contain the word lasagna is an example of a search algorithm. We have to search some kind of data structure, in this case, a database, for records which satisfy some condition. But the question is, how do we do this? How do things like MySQL and MariaDB, how do they find this stuff, and how do they do it so quick? Well, we might talk about it in later videos, but the simple answer is very good, very optimized search algorithms. Here's another example. We have an array here with 6 things in there, sorted in no particular order. And one question we might want to ask about this array is, what's the biggest value in this array? Now, this is another search problem. We're not asking directly if it contains something, but we are asking to search the array for the highest value. So this is another search problem. In this case, the algorithm would return the answer 92. And we could go off and do something with that answer. We could show it to the user, and that's a very useful feature to have. Finally, here's another example, and perhaps the silliest of them all. But say we have this sentence, "Oh fudge cakes, I've left the oven on." And let's pretend we're implementing some kind of profanity filter for a chat system, so censoring the words in the sentence. So how might we go about this? How might we go about implementing such a system? Well, one way to do it is to have a list of bad words that we keep somewhere, maybe in a file. Here's an example of this. We have, fudge cakes, barnacles, horseradish, flipping, and heck. And we can look at each word separately in the sentence, like "oh, fudge cakes, I've," and so forth. And we can check and search the list on the right to see if it contains a particular bad word. So in this example, we've searched the list of bad words for fudge cakes, and it exists in the list of bad words. So we can actually end up censoring this. We can actually start doing this. But this is an example of searching words in another list. This is another example of a search algorithm. It's a search algorithm because we're searching the list of bad words for, in this case, the word fudge cakes. And using that information, we can censor the appropriate words. But you can see how useful something like a search algorithm can be, even if it is a silly example like this. They're used so much in software development. I can't stress that enough. We use them all the time, and for that reason, they're worth studying. So that's it for this video, guys. Thank you for listening.